What happens if we take all the known elements to make a self-contained environment, like a terrarium or biosphere 2 on a larger scale? Can we anticipate all the variables, recreate what took Mother Nature millennia to do? Sit back, watch our creation thrive? Can such a thing continue into perpetuity? What about terraforming an environment into something better, as if we know best what that is? Or does it eventually tailspin into oblivion? I mean, as we change landscapes irrevocably in this Anthropocene era, invasive plants, they get around, decimate pre-existing ecosystems, take over landscapes, choke out new plants, and then you add to that fires and climate change. It's all wreaking havoc. But should we let those invasive species solve our problem by re-greening a dead landscape? Or are they really solving anything at all? Well, in 2015, a book was published, The New Wild by Fred Pierce, and it tried to challenge science with claims that we should do exactly that. Let newer, stronger plants take over. That invasives, they aren't villains like we make them out to be. And our future depends on them. And stuffy scientists stuck in their old ways are holding us back. And the book's first example was Ascension Island to make this case in the South Atlantic Ocean. So let's talk about Ascension Island. What happened? It's a roughly 34 square mile triangle of volcanic land halfway between Brazil and Angola, Africa, known since the dawn of the 16th century, and it's about 930 miles from any continent, 800 miles from the island of St. Helena south of it, where Napoleon, by the way, was imprisoned in 1815. In fact, that's when Ascension was snapped up by the British to prevent a launching point for Napoleon's rescue. He had already escaped Elba Island a year earlier. And in geological terms, it's a young island at 1 million years, based on potassium-argon dating of the oldest rocks that they've found. And it's perched on the mid-Atlantic ridge, so it does, or did, have volcanic activity up till maybe 500 years ago, just before humans found it. And with such a volatile history, it's no surprise that the first 200 years of its written history described Ascension as a dry, hot, inhospitable, very nearly barren stopping point for sailors to stock up on sea turtles so they could eat something as they crossed the ocean. In 1752, Swedish explorer Per Osbeck wrote that he had never seen a more disagreeable place in all the world than this treeless island. By then, though, there were two new immigrants to the island, rodents, presumably waterlogged survivors of a 1701 shipwreck, and goats, believed to be a Portuguese contribution so that they could have some meat and milk on subsequent visits. And those scrawny beasts, they survived on some grass around the island in the meantime. In 1775, the naturalist George Forster, he visited with James Cook, and he said the island consisted of a ruinous heap of rocks, and in the center of that island rises a broad white mountain of great height, from which grows some verdure, from whence it is obtained the name of Green Mountain, which is a name that would soon become even more appropriate. And when the British permanently settled in 1815, there was very little fresh water on the island. And over the decades, different springs, really just seeps, would be found supplying a bare minimum of water for residents, and gardening was just not very easy. A few vegetables were grown, a couple of fruit trees up on the cooler mountaintop, and in July of 1836, Charles Darwin, he stopped on the island on his way home from that famous trip on the HMS Beagle. And he noted the few fruit trees and garden veggies planted up on Green Mountain. And, he commented on a little livestock, cats, rats, grasshoppers. But his comments damned the rest of the island as entirely destitute of trees, in which, and in every other respect, it is far inferior to St. Helena. And the witty people of that latter place say, "We know we live on a rock, but the poor people of Ascension live on a cinder." So, no surprise when 7 years later, 1843, a visiting botanist, Joseph Hooker, was asked to give recommendations to the Admiralty to improve life there. And to conserve what little water and rain they got, and of course boost the island's productivity, he suggested four main steps. One, primarily, plant trees on the mountain, based on a now long discredited theory that rain follows the plow. Of course, despite that falsehood, the mist at the top of the mountain certainly gave plants a livable place, increasing capture of cloud mist that would hit the mountain, build up, and collect on leaves and drip down. Two, more soil, more plants as more litter, and more litter is more nutrients for vegetation on steeper slopes. And three, planting more drought-tolerant trees and shrubs in the lower areas that have even less moisture. And four, of course, put crops and gardens up on Green Mountain. Okay, well, the first seedlings of this effort came from Argentina in 1845, and a new farm manager was added in 1847 with a mandate: get plants, lots of plants, as many suitable plants as possible from everywhere. And so over the next few decades, thousands of trees and plants were brought, well over 500 species. I don't know, I couldn't find a number, maybe 1,000 different species from Europe, South America, Africa, etc. And by the end of the 1800s, that intentional influx of plant species had mostly ended, and the effort was finally neglected for other interests, and the plants were left to their own devices. Not every species survived. Some common fruit trees like oranges, they struggled and died out, but guava, bamboo, ginger, acacia, cypress, pandans, those did fine. Norfolk pine was planted around 1860 for ship masts. Within 80 years, eucalyptus trees were lining the road, shrubs, Australian pine, palms were everywhere. Sheep grazed on grassy slopes, and plants still, well, today occasionally show up in modern times. Today, tree tobacco has exploded across the lowlands within the last 20 years, for example. And an invasive mango was caught just in the nick of time recently before it could take over the whole island. And of course, to round out that ecosystem, a few animals were added, intentionally or accidentally, over the 2 centuries. Again, rats, mice were added. The goats were 700 strong by the 1820s, actually gone by the 1940s. Rabbits appeared around 1830, though in the 1950s, a lot of them died out through a rabbit epidemic. A few different birds. Cats were around until 2004, brought in to get rid of rats and mice. 100 plus sheep have been there since at least the 1870s. There's 3 different kinds of lizards. There's even a clawed toad in the one little, I think, man-made pond up on the top of Green Mountain. And of course, numerous insects. So today, Green Mountain has a cloud forest of these most adept survivors. Bananas and ginger have gone wild. Bamboo surrounds the pond at the top. Ferns grow on the branches of trees. Lower down, guava has spread everywhere. Mexican thorn, prickly pear, cactus covers the low, dry areas. And ecosystems appear to have flourished on an island that 200 years ago was just a hellscape with some ferns, grass, and purslane. And there are now approximately 300 species growing on the island. So what does it mean? What can we learn? Should we be proud of this? No. Let's start by identifying the losses in this change. Many publications going back to the 16th century, they list the same 10 to 25 plant species on the island that were there before human modification. And we never bothered to pay close attention to bryophytes, that's moss, liverworts, and such, or lichens on the island. So maybe there were more species, but still not a lot of ecological diversity. Now, well, various endemic ferns on Green Mountain have either gone extinct or live on the brink of extinction, hiding in crevices or clinging for dear life to the sides of a cliff, like the rediscovered parsley fern. A spurge common in lower regions, it now ekes out an existence in the toughest volcanic rock locations near the shores with human help and anti-rabbit fences. There were a few grasses, most of which have been smothered out of existence by more aggressive invaders and by grazing, of course. And there was even a shrub that's now long extinct. No clue what else might have been lost. It's remote islands. They often don't get enough scientific attention over the decades. And why do we care? What's so special about those lost species? Well, they're adapted to a harsh environment, hot and dry. And as climate change warms the planet, it would be good to understand how those plants thrive, which is a little hard to do if they're just 150-year-old dried specimens stuck to paper. Some of our most youthful industries have come from discovered plants: rubber, chemical, medicine. We also don't know what other participants of an ecosystem rely on those plants within Ascension, permanently or transient. And I haven't even touched on the native animals we completely neglected to study before they were lost. But back to that book by Fred Pierce. In the New Wild, he puts forward a case for humans stepping back. Let the best suited plants take hold, implying our future depends on that, right? It seems like a plausible argument in dire times. To some degree, maybe we have no choice. But his book goes a step too far, cherry-picking examples and giving little time to really a larger reality of ecology. Yet at the same time, the research that must have gone into that book did not go far enough to understand what was really happening before those opinions were published. For instance, the book describes Green Mountain as a thriving example of a young ecosystem that has, in just 200 years, found balance with complex ecological interactions, not the several millennia that biologists claim such things take. Here, Pierce is referencing ecological fitting, which is coined by Dan Jansen in the 1980s. Pierce uses Jansen's ideas to imply that it may be easier than thought for plants from different circumstances to just fit together and thrive, suggesting that ecosystems are more random than we traditionally think in coevolution theories. But is Ascension truly a thriving, complex ecosystem? No. A fully functioning ecosystem sustains itself. All living things within that environment interact with each other and with the non-living elements in a balanced and sustainable way that includes plants, animals, invertebrates, microbes, non-living factors. They're all cycling nutrients in a cliche succession cycle of life, all energy regenerated. And it's been doing it, refining it so long that it can weather unexpected variations that occur throughout deep time. And that resilience to disturbance is big. But things are not as settled as they seem on Ascension. Life is actually very precarious in that little cloud forest and the island overall, really. Even for the new invasives, many like the aggressive thickets of shell ginger growing as a monoculture. They don't just choke out other species, but also one plant contagion or one extended dry spell that decimates that entire population living in close proximity, and you've lost it all. Farms, they're a great example of the risks of monoculture. And some successes are actually on borrowed time. For example, large ficus microcarpa trees. They stand up there on the mountaintop looking amazing with endemic ferns finding refuge on their branches. Those trees, well, they can't reproduce. They co-evolved with a specific species of fig wasp that's not on the island. So those big happy trees, they're simply 100-year-old originals planted by us with no sex life. So what happens when they die? None of the plants can regenerate. Humans would have to intervene, plant new ones. Not sustainable. Other plants, they might have usable pollination methods, but seedlings can't grow in the thick ground cover. Thanks, shell ginger and everything else growing there. Also, non-living resources, those are finite. The long-used Dampier's spring seep, it's all but dried up. In the 1870s, people were surviving on, believe it or not, a rationing of 1 gallon of water per day from that seep and others. But luckily, since the 1960s, we survive on the island from a couple of desalination plants, but that's a solution for humans. Plants, they don't have that luxury. And with global warming pushing the clouds higher up, that cloud forest is on borrowed time too. It will suffer. So, like I said, a durable, healthy ecosystem can survive external factors, but that takes time. Ascension is not a grand proof of the ecological fitting concept just because a couple of puzzle pieces managed to fit on one side. It doesn't make a full picture. And the idea that we just planted things and stood back, well, we didn't. Many times we've had to stop things from teetering into disaster. The island isn't stable. It's been mostly humans molding and managing that monster that we created, not the plants doing it themselves, really. And if you need a few examples, those goats the Portuguese dropped off before 1700, and they ate everything in sight while they were waiting for us to come and eat them. And they were there until the 1940s when some soldiers killed them during World War II. Rats took over the island in the 1700s. They chewed through several endemic species, bird species. So in the early 1800s, when we got annoyed with them, cats were introduced to combat the problem. And then cats, well, they decided seabirds were just as tasty as rodents and maybe easier to catch. So cats became the problem. And that took us until 2004 to finally eliminate the cat problem. With some fights between humans over some domestic cats that had been killed by accident in the process. Now the rat population is rebounding and expanding its range, and they can't easily be killed without also hurting the native land crab population. Plants, one of the introduced plant species, she oak, I believe, brought with it cottony cushion scale. It's a common plant pest that was spreading to several other plants on the island. So a type of ladybug was introduced in the 1976 to eat the scale. And in the 1960s, in the Two Boats village, Mexican thorn trees were planted to prevent dust and consolidate the soil, keep soils from eroding, slopes from eroding. But now it's taking over the island. So a batch of avipe moths was introduced in 2024, I believe, to control the Mexican thorn through defoliation. A very similar effort was used to control the expansion of prickly pear cactus on Ascension back in 1974 with the cactus moth. In fact, even before that, one guy managed to eradicate prickly pear in the early 20th century, but it only took 3 survivors to repopulate the entire island. So, while it might feel peaceful sitting next to that little pond in the bamboo thicket, it is not an ecosystem in stasis. Change is still a constant. Ascension, it may be remote, but it is not in a glass jar like some closed terrarium. Balance, it'll eventually come with some time and only for some species. But the stronger relationships and more intertwined nature of coevolution, that happens over longer time scales, and it cannot be disregarded in favor of just letting the fittest invaders take over either, because resilience takes time. And we humans, we think in short, misinformed timescales. 2 or 3 human lifespans, that's not a long time. Plants and animals still battle for dominance today, for their place in that young environment. So what do we do with this? I didn't intend this episode to be a critique of a 10-year-old book, but that book makes so many superficial points, ignoring a more complex reality. For example, misrepresenting preservation ecologists as xenophobic elitists trying to keep out foreigner plants, or chasing windmills by trying to replicate complex ecosystems that have long been lost. But I'll tell you, the past cannot be recreated. Pandora's box, it's open. The Anthropocene era has forever changed environments. Nobody knows that better than a preservation ecologist. So a hybrid approach is really our only choice. The 2007 book, Ecological Restoration, made that very clear. And their ideas built on holistic restoration from a 2002 article. The term novel ecosystem, that was coined in 1997 to describe environments like this. And the Lessepian migration between the Red Sea and the Mediterranean caused by the Suez Canal, that's been studied at least since the 1970s. So Pierce's book, yeah, that's way late to the party. Ecological restoration itself is a relatively modern endeavor, solidifying its concepts only 30 or 40 years ago. So it's not really entrenched in old xenophobic ideas. And despite the definition of restoration, it's pretty much understood that many challenges are involved in this effort. We can't bulldoze a landscape and replant endemics. The damage is too far gone. There's no turning back the clock, and we have to temper our efforts. We're now forced to work on coexistence, on new ways to protect endangered species, often focusing on things like site-based approaches rather than species-led efforts, and where we find viable locations to more easily foster and protect the at-risk plants, defending against that plant army that just never seems to run out of soldiers. But even that, manpower, time, those are expensive, and we can't watch things forever. It only takes 1 or 2 changes in world focus to destroy the effort. As an example, grandiose English gardens of the 19th century, they were lost largely when 2 world wars brought together other priorities, right? And the goal is to set an always evolving ecosystem back on a normal trajectory through deep history before rapid degradation by human activity. And even this must be reconciled with the fact that all things are always changing. But also, dealing with the surge of novel ecosystems is not, or should not, be about a laissez-faire attitude. We can't just say, let it be. We now have to pragmatically shepherd our world through a very painful and unstable time for every living thing on the planet. It's the least we can do, considering we're the cause. And it's good to remember that Ascension, opinions aside, is worth our attention. The discrete nature of islands, the evolutionary history of them, it plays a role in understanding biodiversity, ecosystems, and evolution, how these ecosystems work or don't work. When modified, we can learn as those isolated environments wobble between harmony, collapse, or takeover. But just understand that the lesson comes at a cost. The idea of standing back and not fighting for endemic species, we lose even more, like potential new medicines or inventions. Even beyond Earth, Ascension can teach about carbon sequestration in larger trees, in the newly generated soil. The island serves as an example of, how we might quickly create a viable terrarium of man-made complex ecosystems with limited resources, large enough to sustain itself, and maybe humans, maybe on Mars, just with ongoing guidance. And let's pray you solve for everything in that little Mars habitat. Just because a bunch of new species have invaded and built something pretty doesn't mean we have a viable ecosystem. For those invasive species that have smothered all the endemics, it could be a Pyrrhic victory where they too will succumb to that destabilized world that they created. Consider that the next time you look at pretty pictures of Ascension Island.